So today you're going to be looking at resistive circuits and the measurement of voltage and current in parallel. So last week we talked about the measurement of these parameters in series, but today is going to be in parallel. And the aim of the experiment will be the same as last week, except this time, like I said, it's going to be in parallel. So majorly, you're going to notice the difference in this part and this part. So last week we noticed in a series connection the current remains the same, right? So this week you're going to notice that the voltages will remain same. So the apparatuses that we use today will be the power supply, the same power supply, connecting cables, the digital multimeter, and the same resistor we used the last time, right? The only thing that's going to change this time is your connection. It's going to be in parallel. That will be the equation you use. Remember I said the voltages remain the same. Last week we had I12 equals I1 equals I2. Remember? For series. It was I12 equals I1 equals I2, right? Sure. So this week is going to be V12 equals V1 equals V2. So another thing you're going to notice here that is different is R12, the measurement of R12. So last week it was R12 equals R1 plus R2, right?
You're doing it right.
So guys, like I said, remember in experiment 2 in series connection, it was connected side by side, right? Where it was just one connection like this, right? So now in parallel, you need to detach one of them, add another connecting cable, and then merge the two connecting cables. Right? So you have this as your circuit diagram on the board, right? So this is what a parallel connection looks like. So while using the power supply, you're going to connect it see, here's the image in my eyes. Yeah. So first thing we need to do first, of course, measure the resistances of the resistor. Do you guys remember how to find them? How to measure the resistance of your resistor? Okay. So find R1 and then R2 individually, right? So we take the multimeter, right? Change it to 20K, right? I think this should be R2, sorry. Let's start to R1. Right? R1, and then you turn it on. So the resistance of R1 is 9.89 kilo ohms. So we have 9.88 from the last time, but then of course multimeter error, but it's okay, it's negligible, right? And then to find for R2, right? So remember, it's on 20K, right? So because it's higher than 20K, we need to put it to 200, right? And then when you put it to 200, it's going to have a reading of 99.145. But then we have 99.6 on the board, which is still okay to use for the calculation, right? So we turn this off, the power off, and then now we need to check R12. So we need to connect them in parallel to be able to find the resistance, right? We're going to notice, sorry. So now we're back to the connection, right? And then we plug it in. So remember one was 99.6 36 and the other 9.89, right? So it means we leave it at 200K. We can't take it back to 20, right? And then we read. And then we're going to have 8.9, right? Which means it's lower, right? Let's try taking it to 20Ks. 8.98, right? I'm sure you're wondering, it's supposed to be higher, right? Because it's supposed to be R1 plus R2. But remember, it's parallel. It's the inverse. Right? So you're going to verify this using this equation. Can we try that now? So R1 is 9.89, right? Let's put 9.88, right? Multiplied by 99.60, right? And then R2 is 99.60 times, plus. You need to add it. Plus 9.88. Can we please have a calculator? So this, of course, is 109.48, right? And this is what? 9.88 multiplied by 99.60. Anybody? Does anyone have a calculator? Yes.
8.98.
That no, I mean, what's this? What's this number here? 984.048, right? And then you have 8.98. 98 kilo ohms, right? So it means here we need to rub this off, right? And write 8.98. So we checked using the multimeter. Let's go back and be sure that 8.98 is what we got, right? It's about 8.9998. 8.98, right? Yeah. So it means that in parallel, the sum of the resistances of your resistor, right, are lower than their individual resistances, right? But meanwhile, in series, the sum is the total, right? So that's how we've been able to differentiate between measuring the resistance of your resistors in series and in parallel. So let's go to V1, V2, and V12. So following the Kirchhoff's voltage law, right, in parallel, the voltages are the same, right, throughout the circuit, right? So let's check and verify to be sure that what Kirchhoff said is right. So we'll connect this here and here. Thank you. Today we'll be using reference voltage of 10 volts and not 5 volts. Remember, it's in parallel, right? So if you look at the circuit diagram, you can see that the voltages are up here, right? From the connection, right? So it means that, yes, thank you. So we have extra cables. First, you change it to 20V, right? Because it's 10V that's going through, right? We're expecting that the voltages are going to be the same throughout V1, V2, and V12, right? So remember last week, V12 was here, so we measured it in series, right? You guys follow me? Yes. Okay. And then the V1 and the V2 were measured in parallel, right? But then because it's a parallel, the parallel connection, V1 and V2, V12 will also be measured in parallel, right? So let's check this. So what you need to do is take two more cables. So this has to do with more cables, and then you plug it in here. Is it off, please? Yes. Okay. So you put this in here. I mean for V12 to measure the voltage going through here and here. Does that make sense?
Yes.
Does that make any sense? So it's like saying, like if you look at that circuit diagram, right? You see V12 is down, right? So it means for all of them, right? Because remember, see here, they're connected to, like both resistors are connected, right? So to be able to find it, you need to connect two more cables to it at this end here. Don't detach anything, right? And then you put them in here. Volts and comport, right? Can you please turn it on? Thank you. Here you have, can you please turn it off, please? Off. It's negative because I didn't check the polarity. So this here is negative, so come, right? And then on, please. And on we have
10.95.
we have like 10.965. 5.6 is fine, right? Okay, can you just come back? So that's for V12, right? So we're expecting that the V1 and V2 should be the same. So back to this. So we need to see the voltage going here, right? So it means we do, sorry? R2. So people follow me. So this is R1, right? So it looks like that connection, right? I mean for that one, for V1. Does it look like what we have on the board? So we would like to see, sorry, this is negative. This one, right? But not forgetting that they're still connected, right? We didn't detach anything, they're all still connected. We just need to see what's going in here, right? So can you please turn on the power? Okay, let's try it. Can you please turn that off? A different multimeter. Thank you. Yes, can you please turn it on? Yes, 10.9. It's fluctuating between 5 and 7, so we can pick 6 is fine, or 5. 5, right? Okay. So can you just turn that off? Thank you. So we do the same thing for R2, right? Hold on. Okay. Oh, sorry, can you please turn it on? Thank you. It's changing. This is about 10.8. about 10.75, right? It's fluctuating between 7.5 and 8.4. Here, 8.4. So, can you turn it off? Thank you. So this is 10 point. Oh, sorry, this is the calculator. Let me rub this off. 8.98. This is 10.95. This was 10.8. This was 10.84. This was 10.87, I believe. Was it?
Yeah.
So if we approximate it, they're all within the range of what it is, right? 10 or 11, approximately 11. So let's go and check for the current. So this time, remember the last time the current was the same, right? So now the currents are supposed to be different. So if you look at this circuit diagram here, you can see I12, right? So I12 will be measured in series, right? And then apparently the current flows in through here, right? Some go in here and some go in here. So that's why it is split, right? Just like in series, how we saw how the voltages were split. Here, this time the currents are the ones that are being split. So let's start with I12 first. Is it on? So let's take out. I don't think we need to take out anything. Okay. So we need to take this out. This is one, right? So we take this one out, right? And then we put one here, right? So if you take this out, it's no longer in parallel, right? The idea is to keep all of them connected in that particular manner, right? So we just need to see the current going through this one, right? So here is for the positive, right? Sorry, MA, and then this for the COM, right? So we take it to 20 milliamperes, right? And then, but hold on a second. Yes, let's put this to bridge. Don't want them to touch it, please. Can you please turn it on? Thank you. So here we have 1.05, right? Can you please turn it on? Perfect. This is for I1, right? Let's check I2 and then I12. So disconnect, right? You take this out back. Let's make the connection complete again so we know what we're doing. This is complete again, right?
Yeah.
So put it back. Now we take one of this one, right? Thank you. Extra cable this way. This one is to positive, thank you. And the other one is to the negative. So we still leave it at 20 milliamperes, right? Turn it on. Can you please turn it on? Turn it on and it's 0.13. Oh, thank you. So here we have 0.13. So now we're going to check I12 to be sure that I12 is the summation of what goes into I1 and I2, right? Let's make the connection complete again. Right? Remember we're going to check it in series, right? So it means we put this one here in the negative, right? negative, right? Extra cable, positive, positive, right? In series, right? Okay, can you please turn it on? Can we use another multimeter, please? Oh. This one. This one. This is positive. This is negative, right? Can you please turn it on? Oh, sorry. This is between T, A, and this on. This one is worse. This one is worse. The current will be measured in series, just like that circuit diagram there. So what you need to do is detach this one, or any one, right? And then this is positive, so you put it in the positive, right? And then this one in the COM port. Does it make sense? I'm saying in series. Oh, this is positive. Sorry. No, it's positive, it's correct. Oh, no, sorry. Negative and then positive, right? So, this is the connection, right? Still in series, and then, can you please turn on? Wait, hold on. Yes, turn on. 1.14, right? Can you please power off? So this is 1.14. So if we're to find I12 will be equals to I1 plus I2, which will be equal to 1.05 plus 0.13, which will be equal to 1.18, which is still not far from 1.14, except maybe you try and do the connection again, but then of course the multimeter gives fluctuating numbers, right? So this has been settled. So based off on this, we can see here, following the Kirchhoff's voltage law, right? We've seen that the voltage remains the same in a parallel series, right? Approximately the same. The higher the resistance, the lower the current, right? So we can see here that the higher resistance has a lower current, right? And then the lower resistor has a higher current. And then of course, this is the regular Ohm's law, right? This is just for Ohm's law reference. Increase in voltage equals increase in current, right? But then it does not apply for this in parallel, because here the voltages are the same, right? We're expecting that the current will be the same, but then in a parallel series, right, this does not necessarily apply. It only applies to a series connection and a simple circuit. But in parallel, it's not the same. So you have to calculate these values which we calculated here, right? We calculated their resistance. We measured the resistance, which is equal to the calculated resistance. The voltage should be the same here, right? And then the current is what we did here. And that sums up experiment 3. Do you guys have any questions? No questions? Or do you guys want to try it out? Lay your hands on it, play around with it for a while. Yes, no, yes? Please say yes. It's allowed. You should want to touch it.
Yes.
Okay, so if you want to try it, please come and try anything you want on this board. I mean, choose R1, try and find R1 or find R12. I mean, with the connection here. Yeah, feel free to try it out. Which would you like to try?
I
I1.
Yeah.
Okay. Maybe remove this, make it a complete circuit first, and then remove what's is, yes, not right. Yeah. Yeah, the black one is 1, the other one is 2. Try again. You know, this completes, this completes this, right? So try and find I1. This is 1. What you can do is this one, right? So this is going to be the 1 point. So you see, it's fluctuating, but yeah, that's how to check for individual items. Is any other person on the chat? Okay, so since you guys don't want to try, for resistors network, we will just talk and you will connect it by yourself. Is that good? Because it means you understand the series and parallel connection, right? So it means when we give you the resistors network with 5 different resistors, you're going to not make mistakes. Okay, so, oh yeah, is there a lab next week? There's no lab next week, so I think next week is your midterm break. So you won't need to come here for the midterm. Please look at your syllabus to know when next you have a class, and so you can also prepare for your quiz before the class. Of course, it can't be this weekend because you have your midterm, right?